the graduate student who was working on that came into my office and said, we've got a photovoltaic, we've got something that can really do power conversion. And, together we just looked into, well, how important is that? Because, of course, there's something about the infrared colors that's a bit intangible. They're colors that you and I can't see. And so you don't necessarily appreciate them. But we recognize that, in fact, half the sun's energy reaching the Earth, in fact, a little bit more than that, is actually invisible to us. So it's just
in that infrared range?
It's in that infrared, yeah. Infrared means beyond red, so it's beyond what you and I can see, but it's just as real as anything, as any other source of power. And if we don't tap into it in our solar cells, then we throw away more than half of the potential sun's energy that we could be using. The passion that the PhD students and postdoctoral fellows who bring to this work is remarkable. And they're working 20 hours a day in the lab in order to get there. We recognize that solar energy isn't just an incredibly exciting science problem, which it is, but that it's an incredibly important human problem. And this is something that we think about every day unabashedly.
You do, right?
Yeah.
Well, tell me about some of the conversations that come out of that.
Well, these kinds of considerations of how to get the efficiency up. Can we get another factor of 3 doing this or another factor of 10 doing that? And every once in a while in one of our meetings where we're making this systematic progress towards this goal, I'll say, listen guys, this is great and we're optimizing and we're improving, but we need a revolution here. We need something that's going to take us to the next level. Sometimes the grad students will say, well, that's true, but we just got a factor of 3 through systematic optimization over the last week. If we can give you another factor of 3 2 times, that's a factor of 10, and that's a revolution. I think I remember a time when it wasn't so much on my mind. And then you go outside and you stand in the sun and it beats down on you. I mean, it's incredibly powerful. And you can't but wonder, surely there has to be enough energy there for a civilization, for something as small as the Earth. And indeed there is. And of course it's been powering life forever. I mean, this is our only energy source. It's the sun that feeds plants that ultimately feed us. Clearly its power is vast and one that's largely untapped. And as scientists and engineers, it's incumbent on us to try to figure out how to make this something that we can tap into in a way that's practical. And you can almost say, and of course this is ignoring the practicalities of where we are today, but you could almost say, well, abundant, free, and clean, why would we do anything else? Well, the answer is that we haven't yet engineered our way through this. The limitations today are technological, and ultimately that means that they're human. They're things that we haven't yet discovered. And that, of course, is what engineers do. They break assumptions.